Hello children, I hope you are in class 9 or probably you're in pursuit of this topic as you're preparing for some competition like probably ACT or say SAT or probably banking, might be NDA, CA, etc. Well, doesn't matter. What I require you to do is to be able to understand this in so good a way that any sum comes your way of recurring decimals, you're able to deal with it with utmost ease. Okay. So remember children that whenever we talk about recurring decimals, it's actually a type of a rational number, right? So what is a rational number? So whenever we have a set which is something like this, that q is equal to x is such that x is equal to p upon q, where p and q are from the set of integers, q is never equal to 0, and further p and q are coprime. So this is the sufficient definition of a rational number. So here what have we learned is the rational numbers will be represented by capital Q, right? Now if we talk about any rational number, we can consider it to be say some x. For that matter, this is actually how we write a set in the rule method or in the set builder method, where using the rules you can then make your requisite set, right? For that matter, always remember that set is a collection of well-defined objects. As such, whatever the definition is, always it will make sure that the stipulations, the rules are always followed and the same meaning is conferred again and again and again, right? So here when we talk about a rational number, we were talking about say some x which is representing it, and that is equal to p upon q, where p and q both are from the set of integers. Now if we talk about the set of integers, do remember that it is either represented by capital I or sometimes it is also represented by capital Z, and that is given by say -3, -2, -1, 0, 1, 2, 3, and all of this continues up to infinity on the right hand side, and on the left hand side all of this will continue up to -infinity, and this children is the set I of integers. So in the set of rational numbers, we just looked up one thing, that it is represented by q, right? And in such sort of numbers you have to see that the numbers are of the form of p upon q, right? Just like this, where p and q are from the set of integers like we just discussed. It can be of any of this, but you got to take care that q, the denominator, should not be equal to 0, because if you have a number which has the denominator to be 0, say something like 14 upon 0, this will be a defunct number, or this is something which is not admissible, this is something which is not acceptable in mathematics, right? So as such, q is to be not 0, right? Now the next thing children is an interesting thing which normally children forget in writing the definition of a rational number, and this is something which is quintessential. You got to remember that p and q, that is the numerator and the denominator, are to be coprime. Now coprime means that there should be no other common factor except one among them. So if say we talk about a rational number which is like 4 upon 25, now here you find that among 4 and 25 there are no common factors, as 4 obviously is 2 square and 25 is 5 square. So as such, the only common factor which is available among them is 1, and when such is the case, you say that the digits which are in the numerator and the denominator, they are coprime, right? So this is a requisite of a fraction which is to be a rational number. You got to ensure that the numerator and the denominator, although they may not be prime numbers, but even then they should be coprime, or in other words, the only common factor among them should be 1, right? So this is how you find out rational numbers. Next, now after having rational numbers, a type of a rational number is when we talk about a recurring decimal, right? So whenever we talk about a recurring decimal, children, then a recurring decimal, you can write in your copies, is also known as a non-terminating, because it's not going to terminate, right? And repeating decimal, because it keeps repeating. So if you have a 3 which comes as the recurring part, so that will keep coming, and it'll come for infinite number of times. As such, you can't count it, and you can't consider that at a point of time it will end, right? It will just keep continuing. So whenever we talk about recurring decimals, you've got to remember that they are a type of rational numbers, and they are those which are also known as non-terminating and repeating decimals, as actually they don't end or terminate, and they keep repeating, right? Okay, now as this is one of the type of decimal numbers, in times to come in another lecture I'll be discussing what are the different type of decimal numbers we have, and how is it that recurring decimals are different from it. Okay, now our task is primarily in this lecture to be able to convert the recurring decimals to fractions. That means in the form of P upon Q. Now when we talk about these fractions, these have a special name. So our task is to convert the recurring decimals to fractional format. So let's say we have a recurring decimal. So when we convert it to a fraction, right, then that fraction is known as a vulgar fraction, right? Or it is also known as a simple fraction, right? Now, why is it known as a vulgar fraction? That's because if you try and calculate it, it will come out like a recurring decimal, right? That means it is something which is not going to end, and it will keep repeating. As such, there is a little bit of mathematical vulgarity about it, right? Okay, now children, having understood recurring decimal, that it can be converted to a fraction of the form of P upon Q, that is a vulgar fraction or a simple fraction. Now let's quickly look up what is going to be the process for it. Now there is a sum. First, I'd like you people to try out the sum, right? If you stumble, then do look up what the solution is, and after that do the sum once more. For that matter, children, I expect you people to be seated at a place which is secluded. That means there is no disturbance, there's nobody around you, so that they can't cause any disturbance to you. You don't have any gadgets like television, laptop, mobile, etc., which are there to disturb you at any point of time. Moreover, you are focused completely where the teacher's pointer is, and you also have to sit on a table and chair so that you can focus the maximum. These are some golden rules to be able to understand things in just one time, and as such they are pretty important, because if you try and learn something for the second time, you'll be bored. If you try and learn something for the third time, you'll be further bored. And in times to come, if you keep learning something for a lot number of times, you tend to feel that probably you'll not be able to do it, and you'll be overwhelmed. As such, why not do it best when you do it for the first time, right? So let's do it this way. Okay, now we have this. I want you people, like I told you, to try out for a little period of time, and your time starts now. I will be able to give you a very small fragment of a time when I'll let you people try it out. But what you can do is you can pause the lecture and you can give a longer try in accordance with the knowledge that you already have, or even if you don't have it, just try and reflect. Might be you develop one such method which yet the mathematicians haven't seen, right? Okay, so here we've got to find out a vulgar fraction, and this is to be from the recurring decimal, which is 0.235 prime. Now prime means it's a straight line which is horizontal, which has been drawn on top of the repeating part of the decimal. So this shows that this is going to come again and again and again, and you won't be able to count the number of agains, right? As such, it will be infinite. So the first thing, children, that we can do here is we can assume that this number, which is a recurring decimal which has to be converted to a vulgar fraction, to be assumed to be, say, some x. So let x be equal to 0.235, and then we have a prime. Remember, this can also be written something like this. That is, this can be written as 0.235, and on 3 you have a dot, and on 5 also you have a dot, which shows that these are the two digits which will keep coming again and again and again. This is another way of representing recurring decimals. Okay, now that you have this and you've considered this assumption, remember one thing: if there is one digit which is after the decimal point which is not repeating, right, you require to bring that one digit, or probably you can even be having a group of digits, right, which require to be once brought before the decimal point. Now, in order to bring it before the decimal point, you require to multiply this equation, if this be equation number 1, with 10, right? So this is going to be the first step. That is, we're going to multiply this first equation, equation number 1, by 10, and then we will bring the non-repeating part in front of the decimal. As such, then we will have 10x, which will then become equal to 2.353535. Now I'll actually write what the recurring decimal is so as to show you its power. Okay, now children, we get to see here that actually 0.35 is the recurring part. Now the next step that you require to do is bring this repeating part once before the decimal. That means, as there are two places, so you require to multiply the above equation by 10 raised to the power 2, so that 35 can come over on the left hand side of the decimal point. So this, children, is going to be the next step. That is this above equation, which now you can mark to be equation number 2, can be multiplied with 100, right? And when you do so, then here, children, you will be getting 1000, as it was already 10 multiplied by 100 will be 1000x, which will become equal to 235, and again you will have that recurring part, that is 35, right? Dot dot dot. I'll at least write this 3 times to show that this is some nuisance that you got to remove, right? Okay, so this, children, now can be marked to be the third equation. And further, now what we can do is, if, say, from the third equation we subtract the second equation, then we'll be helped out in finding out the vulgar fraction. So on the left hand side, it's going to be 1000x, from which you are going to subtract 10x, right? And then on the right hand side, you now have here 235.353535, and then you talk about the number which is on the left hand side, on the right hand side of equation number 2, that is 2.353535, right? And remember, children, all of this continues up to infinity. 3 dots shows that this is going to continue in the same way up to you never know when, right? Okay, now when you subtract both of these sides, you get to see that on the left hand side you are going to get 990, right? So as such, you have 990 on the left hand side, right? And further, then on the right hand side, now the recurring part will easily get cancelled, right? And you will then have got 0 for all the numbers which are after the decimal point, and before the decimal point in the whole numbers. From 235, when you subtract 2, you will get 233, right? Now this 990 also had x with it, because in both of the terms, 1000 and 10x, the common factor is x. As such, when it is taken outside, then 1000 minus 10 will become equal to 990. Now further, children, next what you do is, if you make x the subroot of the equation, it will then become equal to 233, which is going to be divided by 990. Now it feels as though there is no common factor, because we can't get to see that there is any common factor with 2, 3 or 5, right? As such, for the time being, we will consider that this is actually the vulgar fraction which was required, right? Might be at certain times there are some factors, right, with which something cannot be divided, but you can't get to it, so it doesn't matter, you can just leave it as it is. So this then becomes the vulgar fraction, as you followed all the steps, right? And if you get to see the common factor, then obviously you can cancel it off. Now there's another thing that you can see, that if you talk about 99, it's actually 3 into 3 into 11 into 5 into 2, right? This above number is not going to be divisible by 5, it is not divisible by 2, it is not divisible by 3, so it will also be not divisible by 9. It can be divisible by 11. That is what we will check. So if 11 twos is 22, one remainder, it will become 13. Again, that is also not going to be divisible by 11. As such, you will say that both of these, if they are to be called prime numbers, probably they are not, but at least they are coprime, and thus you can say that this is going to be from the set of rational numbers, and thus you have converted a recurring decimal to a vulgar fraction or a simple fraction. So all of this process, children, I will quickly repeat, but before that I'll repeat something which is more advantageous to you. If you've been till here and you're understanding and liking things, I know you will like it more if you get more of it with a lot of variety and a lot of activities. So there is a form which is there in the description of the video or in the bio. You get to it, fill up the form and just send it. It's going to come to me, and then I'm going to come over to you and I'm going to ask you what your problem is, and then I will be associating with you, taking you to a live class, giving you some courses and all other features and other entities, my resources that I have to make sure that you become perfect tomorrow and you can get a perfect 100. Do you want it? Right, then you should click on the link and tell me your particulars so that I can come to you and get you to all of these different features and the things that I have as resources, right? So next, now after I have told you about this gift, right, there is another gift, right? The moment you fill up the form, I'm going to come back to you with a small course, right, by emails, which is going to help you on a regular basis to be able to learn a topic, right? So just tell me which topic you want to learn, which is one thing in which you're going to be helped, and I'm sure I'm going to send you with help that you will really say that it helped you out. Now children, as you know that I'm going to give you a second explanation so that I am able to ensure that everything has been understood without any ambiguity. So what do I do is, first I consider this number which has to be converted to a vulgar fraction, a recurring decimal, to be say some x, right? So x becomes equal to 0.235, and on it there is a prime which shows that this is actually the recurring part, and this is going to come for an infinite number of times after this, right? And this can also be written by writing 2 dots on top of the numbers which are repeating. So if suppose there would have been 5 digits which would have been repeating, then on all of those 5 digits you would have either written a prime or a horizontal line, or you would have put individually on all of those numbers dots on top of them, right? So now you have considered this recurring decimal to be say some variable x, and you get to see that there is a number which is after the decimal point and is not repeating. For such a sort of a case, the first thing that you should do is you should bring such numbers which are not part of the group of recurring digits, right, in front of the decimal point, that means on the left hand side. Now in order to do it, you require to multiply it by 10 raised to the power 1, as there is one such digit. But if suppose there would have been 3 such digits, then you would have had to multiply the above equation number 1 with 10 raised to the power 3. So here when we multiply it with 10 raised to the power 1, we will now get 10x on the left hand side, and on the right hand side it is going to become equal to 2.353535 and so on. This is going to continue with these 3 dots up to infinity. Now as you find that this is something like a nuisance, that's why it's been written, so that in times to come when it has been shown to you that this can be removed, right, I'm sure a lot of your worries will also be removed, right? Okay, next now what we do is, whatever are the recurring parts, that means those digits which repeat after the decimal point, you should be knowing their number, right? Here it's 2, it can be 5, or it can be 7, whatever. Now whatever it is, that number you've got to pick up, the number of digits that are repeating, and 10 raised to that number is going to be that number with which you will be multiplying the above equation. So as there are two digits which are repeating here, so with 10 raised to the power 2 or 100 you require to multiply the above equation, and as such it becomes equal to 10 into 100, that is 1000x, which becomes equal to, here you will have two digits which will come over from the left hand side, from the right hand side to the left hand side or the decimal point, and that will become 235.353535 and so on up to infinity. You must be wondering, how did 135 more come, as one has already been taken to the left hand side. Moreover, do remember that these are infinite 3535s. As such, if we take one out of it, there won't be any difference. As such, it will still remain to be infinite number of 35s, which is a added problem, which you'll get to see that is going to be removed soon. So here now what we do is, if from the third equation we subtract the second equation, we will get on the left hand side 1000, from which 10x is going to be subtracted, and on the right hand side we will get to see that we will have 235.353535 and so on up to infinity, from which 2.353535 is going to be subtracted. Just look at both of these equations right hand sides. Now you find that as we have the recurring digits which are identical, as such they will get cancelled, and as such you will just be left out with 235, from which 2 is to be subtracted, and that becomes 233, right? And thus you now have a simple right hand side without the recurring part. Now you will bring over the coefficient of the left hand side to the denominator of the right hand side. As such, x becomes equal to 233 divided by 990. This numerator and denominator doesn't have a common factor of 2, doesn't have a common factor of 5, doesn't have a common factor of 11, right? As such, you can say that this pair is actually coprime. That means except 1 there is no other common factor. As such, x to be a vulgar fraction from a recurring decimal is actually 233 divided by 990, and as you see that this is in the form of a fraction, and this is perfectly following the definition of a rational number, that is, it is in the form of p upon q, where p and q are from the set of rational integers. Q is not equal to 0 and p and q are coprime. As such, you can say that this is an element of rational numbers, and thus you've converted the recurring decimal to a vulgar fraction. So is this clear with everybody? Sure. Okay, so how did you like this lecture? What all you learned in this lecture? What is more that you like to know, right? And how is it more that I can help you out? Make sure to write it as a comment. And if you've been till the end of this lecture and you've been able to understand everything, I'm sure you'd like to know more in times to come. For that, do subscribe to the channel. There will be different notifications, for which you should also click on the bell icon, right? Because in times to come, such are the questions which are also going to be asked, or probably questions which are built with these concepts in the competitions, right? Because you remember my logo is join, journey, join, joyous journey, right? So we are actually targeting from education to employment. That means first you learn something, and then tomorrow you are able to employ yourself with it, because that is the primary target that you have when you go into a school or a college, to be able to learn something, to be able to make your life in the way that you want to make it tomorrow, right? So this education is going to be really helpful in taking you in a joyous journey, right, where you at the moment educate yourself, and tomorrow you get employed, or probably you can even give employment to people, right? So make sure that you're always happy, and make sure that you do the sum once in your copies, and if possible, send me an email to the themathematicshelpline@gmail.com. This click of the page where you have copied the concept and when you've done the sum all on your own, right? And I'll be very happy, and I'll check and I'll send it back to you, right? So bye, join my community, or being joyous, right? And then I'll make sure that I'll make you the best derivative of what you can become. Bye.